As promised, this will be the second screencast relative to ionizing radiation, and you might call this one Radiation Ecology. I actually took a course in that. As I mentioned earlier, the Arid Lands Ecology Reserve and my work over there was what got me initially interested in radiation. And I needed to mention that this was a part of the Hanford Works Reservation, a very secure site down on the Columbia River, where parts of the first nuclear bombs were built and where a lot of spent nuclear fuel and nuclear waste is stored. In fact, today at Richland, Washington, it's really a boom town for jobs because the government is spending a tremendous amount of money cleaning up this site. And the sites along the Columbia River anyway. And then when I worked on my PhD, I was in central Idaho, near Arco, on the National Reactor Testing Site. This is a 500,000 acres of land that houses over 50 reactors, where a lot of the nuclear fuels for the Navy are produced. Also where electricity is produced. It was managed by Westinghouse. At least some of the site is. It's a Department of Energy site, and as many of these sites are, it's in a remote location for the protection of the public. There was a serious breeder reactor accident either in the 50s or 60s, I think in the 60s here, but I spent 3 years working on this site near Arco, Idaho, and the habitat in the area really looks like this for as far as the eye can see, and maybe even more like this from a distance. So I'd be out there on the weekends, wouldn't see anybody in particular. Maybe a car would drive by once in a while. Most of the workers lived in Idaho Falls and came on Monday morning by bus and would go home every evening by bus, so it was 60 miles away. As promised, we're going to talk about some of the environmental hazards associated with radioactive fallout and natural background radiation too. During 1945 through 62, many people in the United States were exposed to radiation fallout from iodine-131 from multiple sources. Many of those exposed were children younger than 10 years of age. The population most vulnerable to radiation exposure. This exposure put those children at risk for thyroid and parathyroid disease and cancer of the thyroid. Iodine-131 has a half-life of only about 8 days, but it is a gamma emitter. It's a very powerful emission, and there was a lot of exposure to it. Strontium-90 is one of those products of fallout that is a beta decay. In other words, it is emitting electrons and has a half-life of 28.8 years. So once this gets into your body, it's in there for a long time. And it was deposited on pastures, and it would get into your milk because the cows would eat vegetation that had radioactive dust with strontium-90 on it. It still happens. It gets in the water as glaciers and melt in the mountains in the western United States. What is it? It's a bone seeker. It exhibits biochemical behavior similar to calcium, the next lighter group 2 element. After entering a person, an organism, most often by ingestion with contaminated food or water, but again, because of milk that it got into, after entering the organism, most of the dose, 70–80%, is excreted. But that remains is deposited in your bones and bone marrow with only about 1% remaining in blood and soft tissues. Its presence in bones can cause bone cancer, cancer of nearby tissues, and leukemia. So now, a study of hundreds of thousands of deciduous teeth, that's baby teeth, collected by Dr. Lewis Rice and her colleagues as a part of a baby tooth survey, found a large increase in strontium-90 levels through the 50s and 60s. The study's final results showed that children born in 1963 had levels of strontium-90 in their deciduous teeth 50 times higher than that found in children born in 1950, before the advent of large-scale atomic testing. An article with the study's initial findings was circulated to U.S. President John F. Kennedy in '61 and helped convince him to sign the Partial Nuclear Test Ban Treaty with the United Kingdom and the Soviet Union, ending above-ground nuclear weapons testing. So after that, any testing that was done was below ground. That placed the greatest amounts of nuclear fallout into the atmosphere. So it was the exposure of children to radioactive fallout, which everybody understood would cause cancer, that led to nuclear test ban treaties, the beginnings of which happened under President Kennedy. Okay, let's talk about Cesium-137. The isotope Cesium-135 is a long-lived fission product of uranium, which form in nuclear reactors. But its yield is reduced in most reactors because its predecessor, 135 xenium, is an extremely potent neutron poison and transmutes frequently to stable 136 xenium before it can decay to Cesium-135. I know you have a hard time understanding that. The important thing is cesium is a strong emitter of gamma radiation. Its half-life makes it the principal medium-lived fission product along with strontium-90. Both are responsible for radioactivity of spent nuclear fuel after several years of cooling, up to several hundred years after use. This is why people are trying to figure out where to store nuclear waste, whether we should put it in the Yucca Mountain, inside the earth, deep inside the earth, or whether we should shoot it up onto the moon or someplace out in space. For example, 137 cesium, together with strontium-90, currently generate the largest source of radioactivity generated in the area around Chernobyl disaster. It is not feasible to dispose of this through neutron capture. As a result, it must be allowed to decay. Wow. Although all cesium produced from nuclear fission comes from beta decay of originally more neutron-rich fission products passing through various isotopes of iodine and xenon. Because iodine and xenon are volatile and can diffuse through nuclear fuel or air, radioactive cesium is often created far from the original site of fission. Wow. A very dangerous compound, along with strontium-90, that gets into our food because of nuclear fallout in atmosphere's testing of atom bombs. Now let's talk about radon and radon gas. Radon is a cancer-causing radioactive gas. You can't smell it, you can't see it, and it can be a problem in your home, especially in the basements. Radon is estimated to cause many thousands of deaths each year because when you breathe air containing radon, you can get lung cancer. In fact, the Surgeon General has warned that radon is the second leading cause of lung cancer in the United States today. Only smoking causes more lung cancer deaths. If you smoke and your home has high radon levels, your risk of lung cancer is especially high. In fact, it's 200 times higher than the average citizen would experience. Okay, let's try to understand a little bit more about radon gas. The problem is it's a natural product of the breakdown of uranium, which comes from the center of the earth. it gets trapped in your basement and builds to high concentrations if your basement is not well ventilated. There's an EPA map. Well, maybe not. There it is. There's a map showing the distribution. The pink area shows the highest concentrations in basements and emitted from the ground. There are some areas in Wisconsin, Madison is one, where you have to have your home tested for radon gas before you can sell it. It's required by the real estate agent to make sure that this is done. So radon is formed as a natural part of the normal radioactive decay chain of uranium and thorium. Uranium and thorium have been around since the Earth was formed, and their most common isotope has a very long half-life, 4.5 billion years. Uranium and thorium, radium, and thus radon will continue to occur for millions of years at about the same concentrations as they do now. Radon is responsible for the majority of the public exposure to ionizing radiation. It is often the single largest contributor to an individual's background radiation dose and is the most variable from location to location. Radon gas from natural sources can accumulate in buildings, especially in confined areas such as attics and basements. It can also be found in some spring waters and hot springs. Studies have shown a clear link between breathing high concentrations of radon and incidence of lung cancer. Thus, radon is considered a significant contaminant that affects indoor air quality worldwide. According to the United States Environmental Protection Agency, radon is the second most frequent cause of lung cancer after cigarette smoking. So there you have it. Radon, strontium-90, cesium-137, iodine-131. These are all present in the environment. Radon is the only one that gives you a significant exposure from natural causes. The others were produced mostly and distributed around the world through atomic bomb tests in the atmosphere, like the ones you saw in the first screencast showing the videos of atomic bomb testing. And you can look more of those up if you're interested. Also, people who fly a lot in airplanes, like airplane pilots in commercial jets, are exposed to higher levels of cosmic radiation because they're closer to it at the high elevations. People who live at certain beaches in the world, there's a few in South America, are exposed to high levels of natural radiation. People who are in Central City, Colorado, have a pretty high exposure to radiation because of the snow melt and the granite outcrops. So there is exposure in the world. Just remember what we saw from the cloud chamber in Berlin. You can do the most good for yourself by not smoking and by staying out of your basement and by ensuring that your basements are very well ventilated. Okay, I hope you learned something about ionizing radiation and nuclear fallout. Thanks.